Hello, HPTNs. Welcome to today's session on decoding the power of big data, unlocking insights for success. I'd like to introduce today's speaker, Sakshi Kumari, who is working as application engineer at Hexaview. We are privileged to have Sakshi Kumari with us, and Sakshi is an expert in big data, PySpark, machine learning, and AWS. She has an extensive experience and knowledge in these domains, and she will be providing us with the valuable insights into the world of big data and its applications. She will be explaining you about all about the fundamentals of big data and the potential applications of big data. So over to you, Sakshi.
Thank you so much for the introduction, Sayed. Hello, everyone. Good afternoon, and a warm welcome to all of you. So, this is a webinar in a series of webinars which Hexaview is hosting. So, today we are going to talk about the power of big data and see how we can decode it to gain the maximum insight for success. So, here are the few topics which we are going to discuss further. First, we will see what is big data. Next, we will go to how we can characterize something as big data. Then we will look into what are the requirements of big data technology, why it is required, and what's the problem with the traditional technology, why we are switching towards the new big data technology. Next we will see what are the things that is required to develop the big data system. So in this topic, we will discuss about the distributed storage, distributed processing, and the scalability and all. Next, we will move little bit towards the cloud and look into how it is different from the on-premise. And also we will see what are the different types of cloud or what are the advantages of cloud so that because of which it is gaining more popularity. Next, we will go towards the tools or technology which is used to store the big data or which is used to process the big data. And then, since we have learned about the small technology, we will see the overall working flow, how it is used if we talk about the complete pipeline. And at the end, we will look into the application of big data. Okay, so before moving further into the discussion, like what is big data or how we can characterize something as big data, let me take you through a scenario where we can see how big data is trying to solve the problem which we are facing almost daily. So here we will be talking about intelligent traffic management system. We know that since everyone is fed up with traffic, whether it be morning commute or evening rush, so we can think of the problem which is being faced by the traffic. So first thing which comes to our mind is we are having delays in wherever we are going. Second point is we are facing difficulty in estimating the travel time, like what time we will reach and all. And these all problems in turn results in the wastage of fuel and causes pollution, and this problem goes on. So there are analysts who are working days and night in order to improve this situation. So how this ITMS works is they are first collecting data from the various sources. So first source of data is we have seen cameras set up on the highways or most populated areas of the metropolitan cities. So from there, data is being collected in the form of images, videos, and audios, or sometimes in the form of text as well. And with the text, I mean vehicle number, vehicle speed, and all. So these data is being generated in a huge amount on a day-to-day basis. Other sources of data are advanced sensors, GPS signals, and all. So these things are nowadays being installed in the launched vehicles. So if I talk about these all sources of data, so these are getting collected in a huge number and at a huge speed. So there's the requirement of some technology which could handle this much amount of data and could help us to solve the problems which about the traffic. So let's see the overview of how this ITMS works. So first data is being collected from the various sources and then they are stored somewhere. Then they are being forwarded to the traffic management controller. What this traffic management controller does is they are collecting the data, they are retrieving from wherever it is stored, and then they perform some pre-processing on the data, and then they does some analysis on the data, and then they generate some real time insight out of it. And after this real time insight is generated, that is being transferred to the travel advisor system, and we are directly connecting with the travel advisor system via some application and all, and we can see the real time insights from the applications. So real-time insights like what's the travel time will be there, then if there will be some delay in wherever you are reaching, or if there is some kind of accident on road, so that you can divert your route and change in routes, etc. So these all things are informed to us by the travel advisor system. So now you will ask me that where comes the need of big data? So I have said that data is being generated from various sources. So that, and they are also in different formats, which is difficult for us to store if we use the traditional system. So here the data which is being generated is so huge in number that data can be considered as big data, and the technology which is used to store it or process it, that technology can be termed as big data technology, which we will be looking into it further. So now I have given this scenario so that you can relate to it. If I tell you about the technology which we are using for storing or processing and all. So now let's see what is big data. So if I talk about in layman term, so data which are very large in size, which is a little bit difficult for you to store it in laptop or any single computing machine, that you can term it as big data. Although this is not a formal definition, but yes, you can say it as big data. Let me give you an example. Everyone is using these smartphones. So if we see our smartphone itself is generating large amount of data and in different formats, like phone calls, text, photos, videos. If we are sending emails, so data is being generated in huge number. And if I talk about the number, 40 exabytes of data is being generated in a month. So, and they are in different formats, which is not in rows and columns. And we know that if I talk about traditional things, data was stored in the form of tables and DBMS table and all. So, storing images or videos in the form of table will be quite difficult for us if we are still using the traditional technology. So, now let's see what are the characteristics of big data. So there are various organizations which are formally defining the big data in terms of V's. So if I talk about IBM defines the big data in terms of three V's. This first three V's like volume, variety, and velocity. This can be used to define the big data. But according to me, these five V's can be used to better define the big data. So let's look into it one by one. First is volume. Okay. So volume refers to the amount of data which is being generated on a daily basis and at a very faster rate. So we have seen that if I talk about any organization, data is being generated in a huge number, like terabytes of data is being generated, petabytes of data is being generated. So we need to store it and process it. Right. So let's move towards the next V. Next V is variety. So data which is being generated are in different formats. Sometimes we are getting data in the form of structured data or unstructured data or semi-structured data. We will look into it later. But yes, earlier we were getting the data in the form of Excel or in the form of databases, which is storing data in the form of rows and columns. But right now, as we have seen, we have taken the example of smartphones. Data is coming in the form of images or videos, which is difficult for us to store it in rows and column format. So now let's see, since the data is coming in different formats like structured data or unstructured data, so let's see what is the meaning of that. So we have seen the database table or RDBMS table. So that all things comes under the structured table because it has some schema associated with it, or it has some fixed format, like it will be stored in the form of rows and columns. Next, if I talk about semi-structured, so say in semi-structured data or file, we can say they have some kind of parcel schema associated with it, or we can say they have some kind of format associated with it, and data is not stored in the form of rows and columns. If I give you an example, we are using CSV file, JSON file, or XML file. Basically, in data engineering, we are going for this semi-structured data. So this will CSV file or XML file. This will come under semi-structured data. Next comes the unstructured data. So as we have seen the example of smartphones, images, videos, and all is generated. So these all things will come under unstructured because no schema is associated with it, and there's no specific format of it. Now let's move into another V, that is velocity. Velocity means the speed or pace at which the data is being generated. And if we see the real-time data, we can see it that it is being generated in a huge number, and the data is continuous and massive. Suppose let me give you an example. Suppose Flipkart is running a big billion days, and you want to know what's the number of iPhone or what's the number of laptop that is being sold in the last hour. So your system should be such that it could handle the growing demand of the data, and it could process it, store it, and do all kinds of information analysis and all, and could generate some insight out of it, so that your client or you can see that yes, that much amount of iPhone is being sold in the last 1 hour. Okay, so this is the velocity. Next comes the next V is veracity. Veracity is the quality or correctness of data. So it's not mandatory that your data will always be quality data. Means the data which you will receive, sometimes it will have lots of errors, outliers, missing values, null values and all. So our system should be such so that it could handle all these kinds of incorrectness or inconsistent data. If we look into this example and see this column, mid column, so here all the values lies in decimal, like 4.3, 2.0, 0.1. But this is the value that is 15,000. This we can see that this is the outlier. So our system should be such that it could handle this kind of inconsistent data as well. And then if we see this column, max and min column, we can see few rows don't have any value. So we can call it as incomplete data. Okay, so our system should handle this all these things accordingly. So next V is value. This is the last V and the most important V, because it's not it's our task is not just to store the data. Rather, our task is to generate some insight out of it or generate some value out of it. So value refers to the capability of generating some kinds of insight out of the data. Means whatever the data we are calculating or whatever the data which we are collecting, we could have the capability to generate some kind of insights out of it. So if our data is following these all five V's, we can consider it as big data, or the big data system should have all this kind of V's. Next, let's look into okay, that we are learning the new technology stacks, or why is there need to learn a new technology stack in order to handle the big data? So the answer is quite simple, that since the traditional technology or conventional technology is not able to handle the large amount of data which is being generated at a huge pace and huge in number. So for explaining this, let me bring two concepts into the picture. First is monolithic system and second is distributed system. So first is monolithic system. Mono means one, which means one bigger machine is having all the resources. By resources, I mean compute, memory, and storage. And compute is the using CPU cores, and by memory we are using RAM, and for storage we are using hard disk. So one bigger system is having all the resources, but the requirement comes the next day that you have to increase the memory size to 16 GB. Or suppose the requirement comes that right now you are having the memory size of 8 GB, but next day the requirement comes and you have to work on the 2 terabytes of data. So your system or your laptop will face difficulty in that. But you will have the solution that you will say that okay, you will buy memory. But that will not be the feasible option, because that will be quite costly, as well as it will not give the performance in proportional to the amount which you are investing. So there comes the need of that distributed system. In distributed system, we are having cluster of nodes, or we can say distributed system is made with the combination of nodes. With nodes, and every single node is having its own resources. Like every single node is having its own CPU cores, its own RAM, or its own hard disk. So when the requirement comes, or when the demand grows, we just have to increase the number of nodes by clicking a button or anywhere. So by that, this can be set up. And also we can say that in monolithic system, we are doing the vertical scaling because we are increasing the power of one big machine. But in distributed system, we can say that if I talk about scaling, we can say that we are doing the horizontal scaling because we are increasing the nodes, and it will give the performance in proportional to the amount which you are investing. So for now, I'm taking a break, and let me know if you are having any query or something. Okay. So next, let's start with the what are the factors or things that we have to keep in mind while designing the big data system. As we have seen the scenario, we have seen that data is being collected from the various sources. So, okay, fine. We have collected the data from the various sources. We cannot store all the data, huge amount of data in one system. So there comes the need of storage. And since we cannot store the data at a single place, there comes the need of distributed storage. Fine. Next point comes is it's not our task to just store the data. We have to generate some kind of insights out of it. So here comes the requirement of processing. And since data is not stored at a single place, we are using distributed processing for that, so that we can retrieve the data from different systems, and we can do the parallel processing out of it. Next things which we have to keep in mind is whether our system is scalable or not. By scalability, I mean, suppose right now your system is handling the 10 GB of data, and in future the requirement comes for 100 GB of data. So you have to think, or you have to keep in mind that your system should be able to handle that much growing demand of data, or that 100 GB of data which will be coming into the future. Okay. So these are the few things which you have to keep in mind when you are designing the big data system. So next, let's move a little bit towards the cloud and see how the why the cloud is growing in demand, or why cloud use is growing nowadays. And we will see how cloud is different from the on-premise. So first, let's talk about on-premise. So in on-premise, everything is managed inside the infrastructure. Like if we are using any software or something, that is getting installed inside the infrastructure, and everything is hosted locally. And if we want to use any kind of software or something, we need to purchase it, or we can have the copy of it. Fine. But these things, we don't have to use these all things in cloud, or we can say that these all things are not required in case of cloud. In cloud, there is a third party provider which hosts everything for us. Like there is a cloud service provider, and we can ask for them the resources, and they can give it to us. And also if we use cloud, we are only paying for the resources which we are using, or we are only paying for the services which we are using. There is no upfront cost required, or there is no capital expense required, and all. And also we can scale up and scale down based on the requirement, or based on the growing demands. Okay, so now let's see what are the different types of cloud. So there are three different types of cloud. First is private cloud, first is public cloud, second is private cloud, and third is hybrid cloud. So as the name suggests, public cloud is open to all in order to store and access the information via the internet. So anyone can access it, and we can say that your data is not safe if you are using the public cloud. And also, if I talk about the payment method, you are paying only for the services which you are using. And it is advised, if your data is so confidential, so you should not use public cloud. Public cloud is basically used by the startups and all, so that huge upfront cost is not required. And if there is growing demand, your systems will be scalable and all. And also public cloud is totally managed by the cloud service provider. You can buy anyone, like for AWS, you can use, sorry, for Amazon, you can use AWS. If I talk about Azure, Azure is of Microsoft. And also you can go for GCP, which is of Google. Okay, so next is private cloud. So private cloud, if I talk about bank or any fintech company, they are preferring private cloud because they are having their sensitive data or they have the confidential data, and they can't manage to lose it, or they can't manage their data to get accessible by anyone over the internet. So private cloud is used by the organization to build and manage their own data internally, or it can be managed by the third party as well. Also, private cloud can be deployed by using any open source tools like Eucalyptus or OpenStack. These are things we can use. Next comes the hybrid cloud. So hybrid cloud, as the name suggests, it is a combination of both the public cloud and private cloud. So if I talk about the bigger company, they prefer to use the hybrid cloud because not all the data of them are sensitive data. So the data which is sensitive, they are storing it in private cloud, and the data which are not so confidential, they are storing it in public cloud in order to minimize their cost. Okay, so now let's see what are the advantages of cloud and why we are moving towards cloud. So first advantage is scalability. We know that our demands never remains the same. Sometimes our demand is increased and sometimes it's decreased. So our system should be scalable enough. And if we talk about on-premise, you have to buy the infrastructure, you have to buy the servers and all. You have to maintain the that cooling equipment, hire the technical teams in order to manage the hardware and software. So I would say that if you are going towards the on-premise way, that is not so scalable. But if you will go towards the cloud way, it is easily scalable because you just have to increase the node, and it can be done by the clicking of a button. Next advantage is capex versus opex. Capex is capital expenditure, opex is operational expenditure. By capital expenditure, I mean, if I talk about on-premise, you have to pay for huge upfront cost or capital expenditure in order to buy the servers or in order to buy the space which holds the server. You need also you have to pay for hiring the technical teams, and you have to pay the salary as well to them, and you have to set up the cooling equipments and all. So I would say huge upfront cost is required in on-premise. But if I talk about cloud, we are only paying for the services which we are using, and we don't have to pay any initial cost like for setting up the account or anything. We only have to pay for the services which we are using. Next advantage of cloud is agility. Agility means the ways, what are the problems which we will be facing in setting up the cluster. So if I talk about on-premise, we have seen that we have to buy the infrastructure, we have to buy the servers and all. So that would take even a month to in order to set up. But if I talk about cloud, you could just do it. You could just set up the cluster in just click of a button. So cloud is much more easier. Next is disaster recovery. By disaster recovery, I mean, suppose your system, if I talk about on-premise, all the servers are stored at a single place and some disaster occurs or any unforeseen situation occurs. So at that time, it will be difficult for you to retrieve the data from other places. But in case of cloud, since replica of data is there, so and any unforeseen situation occurs in India, you can still retrieve the data from the US server with little or no delay. Okay, so because of which cloud is advantageous to us. Next is cost effective. So cost effective, if I talk about on-premise, we have to pay huge upfront costs, and there are reasons as well, like buying up infrastructure and all. But if I talk about cloud, you don't have to pay any upfront cost. You only have to pay for the services which you are using. So now, as we have seen, what are the advantages of cloud, or what is cloud, and why we are moving towards cloud, and what are the disadvantages of cloud. let's see if there is some person and he wants to open a startup and he wants to start with just a 50 node cluster. So we will see what will be his or her way if he decides to go with the on-premise way, and what will be his or her way or challenges comes if we go towards the cloud way. So if I talk about on-premise way, first thing is he would need a space in order to store the server, or we can say he need to buy the infrastructure in order to store the server. Next, since he wants to set up a 50 node cluster, he have to buy the 50 servers. Then he have to set up a cooling system. Then also he have to hire a technical team, because in order to install the software and also hardware needs the maintenance part. So initially he have to pay for the huge upfront cost or capex, and also operational expense is also needed, because it's not that initially company will hire the technical team and after that they will remove it, because technical team is required in order to install the software and all and maintain the hardware and all. So operational expense is also needed. Next, important thing is on-premise system are not very scalable. Suppose the requirement comes for 70 node cluster, which means 20 extra node of cluster is required. So if I talk about on-premise, the person have to buy 20 node cluster, and when the requirement is decreased or when the demand is decreased, that 20 nodes cluster will be sitting idle. Okay, but next, let's see if he decides to go towards the cloud way, what are the things he needs to follow up. So first thing is he don't have to buy any infrastructure or anything related to that. That all things is taken care by the cloud provider. Second thing is that I have said that they are not required to buy any servers. Next is setup ability. As I said, the advantages that setting up the cluster in cloud will be just done by the clicking of a button. Next is low maintenance cost, because we are only paying for the services which we are using. Next is cloud. If I talk about cloud way, it is highly scalable in nature, because nodes can be increased when the demand comes. So now let's see how big data is stored. We have seen the premise way, on-premise, or we have seen the cloud. Now let's see how the big data is stored. So if we are going through the on-premise way, we can store our data in the form of SDFS. SDFS is Hadoop Distributed File System. We will see the architecture of SDFS little later. But before that, let's see the cloud. If we are going towards the cloud, we can store our data in the form of S3 if we are going for AWS, and we can also use ADL as Gen2 if we are going for Azure, and Google Storage is there if we are going for GCP. GCP is Google Cloud Provider. So next, let's see what's the difference in SDFS, or what's the difference comes when we are storing our data in on-premise and when we are storing our data in cloud way. So first difference is, if we are thinking of storing our data in on-premise or SDFS, or we have decided to use SDFS. So first thing is our data will be stored in terms of file, and which is internally stored in the form of blocks in SDFS. But in case of cloud, data is stored in the form of objects, and and that all is having their own unique ID and all, so that its accessibility is easy. The next difference is, in case of SDFS or in case of on-premise, it is not persistent. By persistent, I mean if your cluster is shut down, your data will be lost. But this is not happening in case of cloud. Even if your system is shut down or even if your cluster is terminated, your data is not lost. Last difference is the most important, that in case of on-premise or in case of SDFS, your storage part is tightly coupled with the compute. With this, I mean, even if you are not using the compute part, you have to pay for the compute part. Like if you are only using storage and you are not using compute, then also you have to pay for both the services, because they both are tightly coupled in case of on-premise. But if I talk about cloud, they are not tightly coupled, or I could say they are decoupled, which means If we are using only storage, we can we can only pay for storage part, and if we are going for compute, we can go for compute part. Okay. So now, since we have seen the storage part, next important things comes is what are the tools which we use, or what are the technologies which we use in order to process the big data. So first thing is we can use the Hadoop, and second is Apache Spark. Let's look into the Hadoop first. Okay. So Hadoop was the first framework which was designed to solve the big data problem. And I am calling Hadoop as the framework because it's not just a single tool, rather it is a combination of multiple tools, or it is a combination of multiple technologies. If I talk about the core components of Hadoop, so core component of Hadoop is SDFS, MapReduce, and Yarn. SDFS is used for distributed storage, which means storing part. MapReduce is used for distributed processing, which means processing part. And Yarn is for resource manager, or you can say it's the negotiator. MapReduce is written in the Java language, and it's quite hard to write. I'm not saying that Java is hard, but even for doing a simple task, you have to write a large number of codes. Okay, so these are the core components of Hadoop. Next, let's see what are the see the architecture of SDFS. SDFS was used for storage part. Fine. So SDFS works on the basis of master slave architecture. So, which means we can have one master and multiple slaves. So here there are two most important things: name node and data node. Name node is used as master node, and data node is used as slave node. So we can have multiple slaves and one master. Okay. So if I talk about the function of name node is to hold the metadata of the actual data. Metadata means data about the data. So function of name node is to hold the data about the data, or we can say metadata. And the actual data is stored in the data nodes in the form of blocks. Fine. And suppose let's say we are having a file of size 400 MB. So, and also one more thing, that block size is initially decided to be 128 MB, but admin can change it. He can either decrease it or increase it. So suppose we are having a file size 400 MB and we want to store it in HDFS. So what will happen is, since the file is stored in the form of blocks, 400 MB file will first be divided into multiple blocks of 128 MB. So 4 blocks will be formed. First block will be of 128 MB. This will go in data node 1. Second block will be of 128 MB. This will go in data node 2. Third block will go in data node 3, which is of 128 MB. And the remaining 16 MB will go in data node 4. Okay, so this is how this will be stored, and the name node stores the metadata in the form of table. Like suppose we are talking about file one, so file one is stored, and file one is divided into how many blocks? 4 blocks. So it is divided into 4 blocks. So 4 blocks are stored there: block one, block two, block three, block four, and wherever that block is stored, that data node is also placed there. Like block one is stored in data node one, so there it is written DN1, and the block two is stored in data node two, and similarly it is written for every blocks. Right. So these were the architecture of SDFS. So since okay, next is the ecosystem tools. As I said that Hadoop is a framework, which means that it is made up of various tools or technology. So that three were the main component. But if we have to design the complete pipeline, we have to use the other tools as well. Suppose your data is stored somewhere else, and you have to bring it to the SDFS. So for data movement, you can use the scoop. Scoop is used for the data movement. Next, okay, that you have your data is stored in the SDFS. Next, you have to do the pre-processing and all. For that, you can use the pig. Pig is a scripting language which is used for cleaning the data. Next, you are okay. Find that your data is stored, your data is pre-processed. Next comes the requirement of seeing the data. How you can see the data in the form of tables and rows. So there comes the use of Hive. Hive acts as a SQL kind of Hive provides SQL kind of interface in order to query the data. So next comes the Uzi. Uzi acts as a workflow scheduler. By workflow scheduler, I mean, suppose you are having the three kinds of jobs are there. Fine. So first is MR1. MR1 is MapReduce 1, MapReduce 2, and MapReduce 3. So you know that MapReduce 1 and MapReduce 2 will work at the same time, and MapReduce 3 will work at the end. And these all things is decided to be executed at 8 p.m. night. 8 p.m. So these all things is the used to this all things will be scheduled with the help of Uzi. Next is HBase. HBase is NoSQL database, and we know that NoSQL database is used when we have to retrieve the data in short span of time, or when we are quick searching of some record. So at that time, HBase is used. So we have seen that when you are going towards the on-premise, you are using Hadoop, and Hadoop comes with lots of learning curve and all, and also MapReduce is quite tough to write. So let's see what are the challenges if we are using Hadoop. So first challenges of MapReduce. MapReduce is very slow and hard. MapReduce is slow because every time it is accessing the disk, if it had to write the data or if it had to read the data, it is always going to the disk and read the data from the disk. Or if its work is done or job is completed, it will write the data in the to the disk. Right. So every time disk is involved, so we can say that this MapReduce is slow and hard because for every smaller task we have to write large number of code. Next challenges is we need to learn different components to achieve different tasks. As we have seen for data movement, we have to go for Scoop, and for data cleaning part, we have to learn for Pig. And as we have seen in ecosystem tool, there were different tools required, and we have to learn all these things. So, and each tools is having their own huge learning curve. So learning all these things in order to do just a simple task will be quite difficult for anyone. And next important thing is MapReduce only supports batch processing. By batch processing, I mean if your job is running or if your MapReduce is executing, MapReduce wants that your all the input data should be present at a single time. Then only processing will be started. So, but we know that real-time data is not coming. We know that real-time data is not coming at a single time. Rather, it is streaming data. So, Hadoop is not able to process that. Okay. So, before starting Spark, if you have any question, you can ask it in the chat box.
Yes. Hi, Sakshi. We have one question coming up from Ishita. She wanted to ask that what kind of value addition does big data offer?
Okay. So as we have seen from this scenario that since large amount of data is being collected and data is in the form of different formats, so it is difficult for us to manage all kinds of data at a time, and also because of storing the data, because we are storing the large amount of data, we can generate some kind of insight out of it, and various other industries are also using this large amount of data in order to gain the business processes or in order to gain the business outcomes and all.
Yeah. Thank you, Sakshi.
Okay. So now let's move to Apache Spark. As we have seen that MapReduce was the bottleneck to Hadoop, here Apache Spark comes to the rescue. So if I talk about the definition of Apache Spark in layman terms, so Apache Spark is a general purpose in-memory compute engine. Here three keyword comes. By general purpose, I mean it can be used for data engineering tasks, data science tasks, and machine learning tasks. And with in-memory, I mean, as we have seen that MapReduce is accessing this every time, but this doesn't happen with this Spark. Spark initially, if the requirement comes, it can read from the disk or it can write to the disk. But in between calculation, it can be done in memory. Okay. And the compute engine means if there is larger jobs or bigger tasks, it is divided into smaller tasks, and it is being transferred to various worker nodes are there. It is being transferred to different worker nodes in order to do the parallel processing of data. Okay, now let's see. Yes. Okay, now the question comes to our mind: is the Apache Spark a complete replacement of Hadoop? Like initially, we have seen that for distributed processing, we can go for Hadoop, and now we are learning that Apache Spark. So the question comes to our mind: is the Apache Spark replacement of Hadoop? So the answer is no. Apache Spark is not the replacement of complete Hadoop. Rather, it is a replacement of just a component of Hadoop, which is MapReduce. If you see in this picture, Apache Spark is just replaced with the Hadoop. Apache Spark is just replaced with the MapReduce part of Hadoop and not the complete Hadoop. Okay, we can consider Apache Spark as the plug and play compute engine, which needs any storage or any resource manager in order to function. Which means Spark is not only bound to use SDFS for storage, or it is not bound to use YARN as resource manager. We can use any cloud technology or any cloud services in order to store the data in place of SDFS. Like we can use S3 as well, we can go for ADLS Gen2 as well, and we can go for Google Storage as well in place of SDFS when we are going for Spark. And in case of resource manager, you can either go for Yarn as well, or you can go for Apache's Mesos or Kubernetes as well. Right. So Apache works with Apache acts like a plug and play engine. You can connect it with any storage or any resource manager, and it will work perfectly fine. So now let's see how Apache Spark functions. What is the what's the architecture of Apache Spark? So Apache Spark also works in the form of master slave architecture. By master here, driver program is the master, and there are various worker nodes. They are the slaves. So here as well, we are having just one driver node, and we can have multiple worker node in place of slaves. And every worker node is associated with the executor, which is running the job or which is doing the task. Fine. So what driver program does is it is accessing the main program of the application, and this is how the Spark context is generated. Spark context has the various functionalities like task manager or job manager, task manager, and the batch manager as well. So yes, and another function of Spark context is to whatever code is written by the user, that code is getting converted into a larger job, or how much size job is there, that doesn't matter. But then larger jobs is divided into smaller jobs, and it is being transferred to the different worker node so that executor can start its functioning. So this happens in with this parallel processing is promoted. Like if suppose you are having a job which is having a size 10 GB, so and you are having two executor nodes. So 5 GB work can be done by this worker node, and another will be done by this worker node, so that time taken will be less. And cluster manager is used to allocate the resources or manage the resources. Okay, so now as we have seen everything like storage processing in small parts, let's combine it and see how the pipeline looks like. If okay. So now this is the I have said that data is stored in different places. So initially data is collected from the various sources, like S1 is different data source, S2 is different data source, S3 is different data source. So first, from various data source, data is being collected and is brought to data lake. Data lake means if you are using on-premise, it is SDFS. If you are going for cloud, it is S3, ADLS, Gen2, anything. Okay. So the process of moving data from any other storage to bringing it to data lake, that process is known as ingestion. So with the help of ingestion, we will see what are the ingestion framework. So with the help of ingestion, data is brought to the data lake. Here it is stored, and then comes the processing part. So for processing, you can either go for MapReduce or Spark or Trace, and various compute engines are available. So for processing, you can do that. You can use that. And after processing comes the serving layer, like Power BI, Hexaview, in order to generate the reports and so to the clients. Okay, so this was the complete flow, but let's see if we are going through the on-premise, how it looks like, or we can say what are the frameworks which we use in order to ingest the data or store the data. So initially, data is collected from various sources. So suppose we are talking, since we are talking about on-premise, so suppose data is stored in the database. So from database, we are bringing it to SDFS for storing it. So in between the framework which is being used is Scoop. Scoop acts as an ingestion framework. We have seen it in Hadoop ecosystem tool. So this acts as a ingestion framework, and now the data comes to the SDFS, and again after SDFS you can use now the data is available for processing. For processing, you can either go for MapReduce or you can use Spark, and other processing tools are also available. And Hive can be used as a serving layer. Okay, in order to see how your data looks like, or in order to see the data in the form of table. Like I've said that it provides SQL kind of query interface. Thank you. Now, this was for on-premise. Now, let's see if we want to see the workflow, how it looks like in case of cloud. I'm talking about Azure cloud. So there were multiple data sources, and from there, when you want to bring the data, or when you want to ingest the data to the ADLS Gen2 or Blob, you can use the ingestion framework as Azure Data Factory, and with the help of Azure Data Factory, you can bring the data from the various sources to the storage unit, that is ADLS Gen2. And now comes the processing part. For processing, you can use the Databricks notebook or Synapse. And for querying the data or seeing the data, you can either go for Azure SQL or Cosmos DB. Here, Cosmos DB is a NoSQL database. Okay. So now this is the end of this is the last topic, that is application of big data. We have seen the use of big data, how we can store it, how we can process it, and all. So now let's see what are the areas in which big data is used. So it is used in various other sectors as well, but these are the few sectors in which it is widely used. First is healthcare sector, retail sector, banking and financial services. In banking and financial services, big data is used in order to decrease the risk, or in order to manage the loan as well, or to detect the fraud in trial and all. Media entertainment, I can say that you are watching some kind of series, and similar kind of series is recommended based on your search history and all. So that all things can be done with the help of big data technology. Next is supply chain and manufacturing. Okay, so let's see the use case of big data in retail industry in details. So retail sector is using the big data technology in a larger amount in order to gain the business insight and to increase their profit. So if I talk about first use case of big data in retail industry, first is personalized recommendation. You have seen that you have done this shopping for something, but again the recommendation for similar kind of things are recommended to you. So what analysts are doing is they are accessing all the details, like your browsing history, your purchase behavior, or whatever you are seeing on the social media. So that all things are captured, and based on that, the personalized recommendation things are recommended to you, or promotions is also targeted to you, and also customized offer is available for you. Sometimes you will see on Amazon that you are only getting the offer and others are not applicable for the same offer. So these all things are customized to the different customers. Next use is inventory optimization. So in inventory optimization, analyst is using the historical or real time data based on the sales or return order, stocks and all. And with the help of this, they can forecast the demand, whatever the when the demand increases, what are the products that will be ordered in large number. So and also with this, they can reduce the problem of stock outs or overstocks and all, so that it will be resulting in improved sales and reduced cost. Next is price optimization. So price optimization means suppose uh, there is a thing and that is trending in a particular area. So analysts will look at the competitor price as well in order to fix their own price, and whatever be the trending technology or whatever be the trending things in that area, based on that it will they will set their own price in order to maximize their revenue and in order to maximize the profitability. And so next is supply chain management. So supply chain management, they are analyzing the log data of logistic, transportation, and all in order to optimize this. And this is done in order to reduce the time which is required to serve your request. Like you have ordered something from somewhere. Suppose you are sitting in Delhi and you are ordering from Bangalore. So if the retailer will bring single thing, it will cost them more. So what they does is they are keeping if something is trending in your area, they will keep various quantity of that product in your area's warehouse, and so that will be transportation cost is reduced for the retailer, and this will also improve the stock outs and overstocks problem, and also this will reduce the time required to reach to you. Next is fraud detection. Fraud detection is used in almost all the areas, like your credit card details and all, online transaction, credit card processing. These all details are analyzed, like customer behavior and all these things are analyzed in order to prevent or in order to protect the risk towards the business. Okay. Okay, so with this, we have come to the end of our session. If you are having any query, you can comment it in the chat box. Okay, since there is no question available, thank you everyone for your time. That's it from me. Thank
Yes,
you.
thank you, Sakshi. Thank you for this wonderful session and giving us insights about big data and its potential applications, right? If anyone has any sort of query, please feel free to ask. Otherwise, we can wrap up with this session. Yeah, so thank you, everyone. Thank you all for participating in this session and learning about big data and the fundamentals of big data and its applications. Thank you. We can now wrap up this session.
Thank you so much, everyone.